Hi everyone, today we are going to start 7.5, which is apply the tangent ratio. And our goal is to use the tangent ratio for indirect measurements. Quick review. If we had a right triangle where we knew two of the sides, but we did not know the third side, we would use the Pythagorean theorem. So in this case shown here, if we wanted to solve for x, we would do 6 squared plus 8 squared. When we would do the math, we would end up getting that x is equal to 10. But what if we had an example like this? Could we use the Pythagorean theorem to solve for x? Well, the answer is no. In this case, we have one side length that we know. We're searching for a second side length, but we do know the angle measure. In cases like this, where we're trying to figure out or solve the right triangle, we would use trigonometry. There are three trig ratios that we're going to focus on. A trig ratio is a ratio of the lengths of the two sides in a right triangle. If I look at my right triangle over here, this symbol here is called theta. Theta will give you the measure of that angle. Now, depending on where theta is, you are going to have an opposite side, an adjacent side, and then a hypotenuse, which we've all been working with the hypotenuse in the past. So the opposite side is the side of the triangle that is opposite to where theta is located. The adjacent side would be the side touching theta. Now, if we were to move theta into the other angle measure, our opposite and adjacent side would change. So if I moved theta there, these would have to be switched. And now this side would be opposite because it's on the opposite side of the triangle, and this would be the adjacent side. So depending on where theta is and what sides we know, we would use sine if we knew the opposite side and the hypotenuse. So sine of theta is equal to the ratio or fraction of opposite over hypotenuse. We would use cosine if we knew the adjacent side and the hypotenuse. So cosine of theta is equal to adjacent over hypotenuse. We would use tangent if we knew the opposite side and the adjacent side. So tangent of theta is equal to opposite over adjacent. You will need to know these trig ratios and memorize them. Now I have a nice little video down here that will help you remember sine, cosine, and tangent. And your trick is using the term SOHCAHTOA. Sine is equal to opposite over hypotenuse, so cosine is equal to cosine is equal to adjacent over hypotenuse, ca, and tangent is equal to opposite over adjacent. SOHCAHTOA. In today's lesson, we are going to focus on tangent, where we know the opposite and the adjacent side. We will not know the hypotenuse for the next few examples. All right, so for number 1, we want to find tangent J and tangent K. We're going to write this as a fraction, and then we're going to write it as a decimal to 4 decimal places. All right, so with our first example, I need to circle J, and I want to find tangent. So we know that tangent of theta is equal to opposite over adjacent. So if I'm looking at J is going to be my theta, or angle measure. So tangent of J is equal to, so now I need to figure out what side is opposite of J. Well, it would be 24. Which side is adjacent to J? It would be 32. So 24 over 32 would be my fraction. Now if I wanted to write this as a decimal, it would be 0.75. Next, let's look at the tangent of K. So tangent of k is equal to, we got to look at our tangent. We know tangent is equal to opposite over adjacent. So in this case, the opposite side of k would be 32. And the adjacent side to k would be 24. So if I would write that as a decimal, I would get approximately 1.333. It did say 4 decimal places, so I'll do one more 3 and we're done. Number 2 here, I want to do the same thing. So I'm starting with j. So tangent of theta is equal to opposite over adjacent. So if I'm looking at tangent j, what side is opposite of j? It would be 8. Which side is adjacent to j? In this case, it would be 15. So if I were to plug that in my calculator, the decimal would be 0.5333. Let's find the tangent of angle K. So tangent of angle K, we want to find the ratio. What is the opposite side of K? It would be 15. What is the adjacent side of K? It would be 8. And if I were to write that as a decimal, it'd be 1.8750. Now we're going to use trig to solve for values of x. So for this case, we want to figure out what is x. All right, so I know I'm going to use tangent here because I don't know the hypotenuse. The hypotenuse is gone, so the only ratio that would work that has the opposite side and the adjacent side would be tangent. So tangent of theta is equal to opposite over hypotenuse. Well, what is my theta, or angle measure? It's 32. So tangent of 32 is equal to, what's the opposite side? It would be 11 over, what's the adjacent side? It would be x. Now, I just want to solve for x. So to get x by itself, I notice that it's in the denominator here. Well, to get something out of the denominator, I'm just going to multiply it by itself. So if I multiply each side by x, these x's would then cancel, and I have an x over here. So this simplified to x times tangent of 32 is equal to 11. Now, even though this seems crazy, that's just a number. Tangent of 32 is a number. So to get x by itself, and to get rid of a multiplication of tangent of 32, I'm just going to divide tan of 32 on each side. So this gives me that x is equal to 11 divided by tangent of 32. Now, when you plug this into your calculator, please make sure your calculator is in degree mode or you will not get this answer. If you plug this into your calculator, you should get 17.6. So what does that mean? It means that this side length is approximately 17.6. At a location 30 meters from the base of a flagpole, the angle to the top of the flagpole is 34 degrees. Determine the height of the flagpole to the nearest meter. All right, so here's our diagram. I need to figure out how tall is this flagpole, and so I'm going to call this x. I know I'm going to use tangent here because if I look at my diagram, we have nothing on the hypotenuse, and the only trig function that involves the opposite and adjacent side would be tangent. So tangent of theta is equal to the opposite side over the adjacent side. Well, what is my theta measure? Or angle measure? It'd be 34. So tangent of 34 is equal to, what side is opposite of 34 degrees? It'd be x. What side's adjacent to 34? It'd be 30. So I need to solve for x. Once again, I need to get that 30 out of the denominator, and to do so, I'm going to multiply by 30 on each side. So these 30s cancel, and this gives me 30 times tangent of 34. That's equal to x. Now remember, tangent of 34 is just a number, so I can plug this right into my calculator. And when you do so, you end up getting, and it says round to the nearest meter. So 20 meters is going to be your x value. So what does that mean? That this flagpole is approximately 20 meters tall. At a location 50 feet from the base of a large fir tree, the angle to the top of the tree is 43 degrees. Determine the height of the tree to the nearest foot. So here's my diagram. I need to figure out what is the height. We're going to call that x. So I'm going to be using tangent here once again. So tangent of theta is equal to opposite over adjacent. So what's my theta measure? 43. So tangent of 43 is equal to opposite. Well, the opposite side in this case would be x divided by the adjacent. The adjacent side would be 50. I need to solve for x, so I'm going to multiply by 50 on each side. So that cancels. So 50 times tangent of 43 is equal to x. Plug this right into your calculator, and when you do, you will get approximately 47 feet. That's equal to x, and it did ask us to round to the nearest foot. So 47 feet is the height of this tree. Next, we're going to talk about the angle of depression and angle of elevation. If you were looking at a horizon and you look up, that would be the angle of elevation. If you are in an airplane or somewhere up in the sky and you are looking down, that would be the angle of depression. Now, if you have two horizons, we know that those would be parallel. So we know that the angle of depression and angle of elevation would actually be the same measure because they are alternate interior angles. So here's an example that deals with angle of depression. So a lighthouse keeper at the top of a 200-foot cliff above the ocean shore sees a boat at a distance from the shore. The angle of depression from the lighthouse to the boat is 43 degrees. How far is the boat from the base of the cliff? So we want to figure out, what is this distance x? Well, if I look at my right triangle, I know this is 90 degrees, but I don't have any other angle measures. What I do have is this angle of depression. Well, if that angle is 43, I also know that this angle is 43. Why? Well, they're alternate interior angles. So now that I have all the information needed, I can use tangent of theta, which is opposite over adjacent, to solve for x. So tangent of 43 is equal to, my opposite side is 200. My adjacent side is x. I want to solve for x, so I need to get x out of the denominator. And to do so, I'm going to multiply x by each side so that those cancel. So x times tangent of 43 is equal to 200. I need to divide by tan of 43 on each side to get x by itself. So x is equal to 200 divided by tan of 43, and this is just a number, so I'm going to plug it into my calculator, and when you do so, you get 214.47 feet. What does that mean? Well, it means that the boat is 214.47 feet away from the cliff.